Well, hopefully this time my numbering will be correct. The cinema owners use a generator to continue showing movies during load shedding. The diesel for the generator is stored in a cylindrical diesel tank as shown below. Okay, here's our cylindrical. Cylindrical means that a part of it is circular, right? So the shape of this is circular around, and then it has this height, or if you just turn it around like this, you can see this is it, like, right? Just that they use it lying down, but it's actually a tank with a circle at the top. So if I'm looking from the top part there, I'm going to see, if I'm looking from the side there, I'm going to see a circle like that, right? And that's where this distance is going to be, giving me the diameter. Like, I'm going to see that diameter there. That's the distance that there, which is 3,22, right? Meters. So that's what I'll be looking at. If I look from the side there, that's what I will see. And then this is the height. So if I, like I said, the length or the height, whatever, if I turn it around like this, then I would see it like this, right? So you don't have to like look at it the way they've given it to you. You can turn it around just to understand it properly the way you are used to it. So the information here says that this length here, which is 7.25, and the opening, or the, not the opening, but the width of this, which is the opening, it's by 3.22 wide, and it's circular, right? And then they're saying there's an outlet there for the diesel, and there's a ladder on the other side of it where people go up and they pour the diesel right there, and there's a breathing valve there just to help it release some air. And these little things here are used as stands, so it's sitting on these little things over here. And then it said the stand and all external attachments are made of stainless steel and will not be painted. So when they are painting this tank, they are not going to paint this part, this part, this part, this part, this. That's not going to be painted. And then the base area of these external attachments is, so all of these external attachments, their base is 1 meter squared, right? So they give us the area for the attachments. And then they're saying you can use these to convert the volume to the size of the liquid, right? And then it says all dimension shown are outer measurements. So there's no inner measurements here. Everything is measured from the outside. Okay, use the information above to answer the questions that follow. State the purpose of the breathing valve on the tank. Well, it's to let go of any air that might be in there. So that's what I would say. That the steel used to make the tank is 5 millimeters thick. All around for safety reasons. The tank is filled to 95% capacity. So they're saying, remember when I said that this is how you see the diameter? They say if you look from the side, you will see that there's a thickness there, like that, okay? So if you look at it, this is the material that is used. It has a bit of a thickness like that. Where can I get something? I'm trying to see if I can get something near me that I can show you with it, which is circular. Let's see. I have this here. Let me see. Okay, no, not that. Let's use this. So you see here, there's two parts. There's the outer measurements, which will start from the outside. But then there's this little thickness here. This thickness here makes it different if you measure from the inside or if you measure from the outside, right? So there'll be that slight difference because of the thickness on the sides from this side here and this side here. And I think somebody did ask me a question about this whole thickness thing. I think somebody did ask me about the thickness. So if you measure from the outside going from there to there, and then you go inside and you measure from the inside there and there, you will find that there's a slight difference. The reason is because from the outside, you include this part, whereas when you measure from the inside, you start before it and end before it, right? I hope that explains it. So that's what we're talking about here. If you measure from here all the way here, you are now excluding the thickness. But if the measurement starts from the outside, goes all the way outside, then you include the what does it call it? you include the thickness of the material. They said there all the dimensions are from the outer measurements, which means this includes that. But then they tell us that there's a 5 millimeter thickness, which means on the side here there's a 5 millimeter, and on the side here there's a 5 millimeter. So if we ever need this dimension from the inside, we'll have to minus the thickness from both sides. I hope that helps. Okay, now show that the inner diameter of the tank is 3.21 meters. Okay, before we go there, I just forgot about this now. They're saying that the tank, since the tank is like that, they say when they fill the tank there from the top, they don't fill it up entirely. You know, they don't want to overload it. So what they do is they fill it up to 95%. So it's all the way there. So there's always space there at the top, right? They don't fill it. Have you seen when you fill the electric jug? It has a line. It has a line where you end there, but then there's still some space. And when you plug the water, if you fill it up to there and you plug the water, once it boils, it all comes out, right? So that's what they're talking about here. They're saying we don't fill it up to entirety. We only fill 95% of it, right? And leave the 5% empty. That's what they were talking about, the capacity, okay, which is the volume of that, right? Or the liquid inside. Right, now show that the inner diameter of the tank is 3.21. There, good. Now they're asking this question. So I'm going to start again. I'm going to do a circle, and then I'm going to do the thickness again, right? And then there's this thickness of the material that's here. And they're saying the distance from there all the way through the center to the end, that's called diameter, right, is 3.22 meters. They gave us on the drawing there, they gave it to us there, right? And now they're saying, what if the inner diameter is 3.21 meters? How did we get it? Remember they said the thickness is 5 millimeters. So this part here is 5 millimeters, and this part here is 5 millimeters, right? Now this is meters, and this is millimeters. So now I can't work with that. I have to convert one of it. So which way will I convert? I'm going to change millimeters to meters because they've already given me the answer there, and I want to make sure it comes out like that. But again, you don't have to. You can change the meters to millimeters and then convert the answer back to meters. It's fine. But I don't have to. I can just do the straight up. So 5 millimeters divided by, I'm going to divide by 1,000. If you don't know, there are videos here that show you how to do this. 5 divided by 1,000 will be 0.005. So what I'm going to do then is in 4.2.1, what I'm going to do is, no, that's 4.2.2. What I'm going to do is then calculate the inner diameter. Inner diameter is equal to, and I'm going to take the outer diameter and remove the thickness. 3.2.2 meters minus, so I'm going to take away this part, 0.005 minus this part on this side, 0.005, and I'm going to get what I get. 3.22 minus 0.005 minus 0.005, and the answer is 3.21. Like magic. When it comes out like that, it's like magic. So that is A. Now we go to B. B says calculate the maximum liters of diesel that this tank can hold according to safety regulations. You may use the following formula. Okay, so we're going to use the formula. We're going to use the volume formula and calculate the space of this container. And then we're going to say we are not going to do fill up the entire space. We're only going to fill up 95% of it, and then we're going to calculate the liters. It doesn't matter which we start with, okay? But as long as you have the volume, you have the liters, and then you make sure that the liters are 95%. The formula volume is equal to pi r squared h. Now they're saying we must calculate the liters of diesel. Why are they then giving us volume? volume, if you look there, that's a unit of measurement for volume. Remember when I said meter cubed, I just wrote meter cubed, centimeter cubed, millimeter cubed, and so on is volume, right? So if you look there, it says you can convert volume or the space into the capacity, right? So we can get liters if we have volume. We can actually estimate how much is going to go in there. So I'm going to use the volume of a cylinder formula to calculate the volume of this tank. And then I'm going to try to find out how much diesel goes in there. All right, so the first thing I'm going to need is the formula, of course. And in the formula, my unknown is going to be volume. Therefore, I need radius and I need height. Okay, so now if you go to here, if you go to the question, the statement here, just above this, it says the steel to make the tank is 5 millimeters thick all around for safety reasons. And the tank is filled 95%. So when I get my volume, I'm all going to reduce it to 95%. It's not going to be filled to 100% capacity, right? So I note that. At some point, I'm going to have to use this 95% because we're only going to fill it up to 95%. Okay. Another thing is the thickness of how does that affect? Because I'm not figuring it out because they gave it to me. They said all dimensions are outer dimensions, right? Outer measurements. And therefore, this 32,22 is an outer diameter. So the opening there, from outside, that is 3.22 milliliters, which is an outer diameter. Right now, if I'm going to put diesel here, it's not going to sit where there's a thickness, right? So that's not going to help us. We need to get rid of that. How do I do that? I have this thickness here given to me. So on this side, there's a thickness, and on this side, there's a thickness, and therefore I'm going to reduce this distance all the way to here and get the inner diameter, 3.21 meters, right? So that is our diameter. Now, we are going to take the diameter, 3.21 meters, and we're going to get the radius. So the radius is half, so I'm just going to break it into two pieces, and that is one piece is going to be 3.21 divided by 2, and we get 1,605 meters is our radius, right? We have the radius there. Now, if we look at the tank, this tank is opened there, right? Which means there is a thickness there and on our length. So now we have a length. Now our length, if we're looking at the tank from this direction, it is closed to this side and it has a thickness of 5 millimeters. It is also closed on this side and it has a thickness of 5 millimeters, which means this length also includes a thickness of 5 millimeters this side and a thickness of 5 millimeters on the right. And that length is 7,25 meters. See, I make drawings on my answer sheets. I'm going to help you to mark me with drawings. Okay, so now I'm going to calculate the length, which means the length now is going to be 7,25 minus, remember we converted the 5 millimeters to 0,05. So we're going to minus on the left 0,005 meters minus on the right 0,005 meters. Beautiful. And then we get a 7,24 meters. Now we have our radius. We also have our height or the length, right? Now we're going to go to the formula. Formula says volume is equal to 3,142 multiplied by the radius is squared, multiplied by the height of the tank. Now remember the tank is sleeping like that. You can turn it around to understand that this is the height, right? So make sure you don't confuse the two, don't confuse the diameter with the height, okay? All right, so now we're going to substitute to our volume. The volume is equal to 3,142. Radius is We multiply that by 1,605, that is squared, multiplied by the height of 7,24 meters, right? So let's see. That is 1,605 times 1,605, and that gives us, so volume here is equal to 3,142 multiplied by 2,576025 multiplied by 7,24, and then if you multiply all of that, that will be 3,142 multiplied by 2,57602 multiplied by 7,24, and then you get 58,599,62278 cubic meters, right? And then what we're going to do here is we're going to convert this to liters. Let's find the capacity of this. So the capacity here would be 58.599,62278 cubic meters is equal to, we do not know the capacity of this one. So what we're going to do is we're going to cross multiply, and it's going to be 1 cubic meter multiplied by unknown. You must be tired of this now. 58.599,62278 cubic meters multiplied by 1,000 liters. Just making sure, because I make a lot of mistakes. And here, and that cancels that, and then we're going to use the calculator. 8 liters, right? And then we're just going to do the last part where we're going to say now the diesel that we will actually have here is equal to 585,999. There's only those, okay, 2278 liters multiplied by 95%. Remember, this can be written as a fraction. Therefore, it's 95 divided by 100. So we're going to say times 95 divided by 100. And that is going to be 55669.64, 164 liters. Perfect, done.